is you don't have to predict the future with perfect accuracy through your clairvoyant crystal ball. It takes the pressure off all of those decisions. So if you're watching this video, you've probably got a whole lot of experience with building on-premises HPC clusters. If you're considering building a new system, you're probably thinking about a lot of questions like, how much power do I have? How big is my data center? What's the HVAC going to look like? What's the right network design? What kind of network architecture am I going to use? What storage do I need to buy? What different types of storage do I need to buy, and how much of it? How much of it can I afford to have? What's the power backup system like, the power generators, the failover circuitry? And then you get finally to the end and you start thinking about the compute. How much compute do I need? What kind of compute is it? Do I need GPUs? Do I need CPUs? Do I need different types of memory models? How far am I away from the next iteration in those CPUs and GPUs coming? Should I wait? Should I go now? There's like a billion questions before you even get to running your first job. And that's probably why it takes so long to build a cluster. When we do that stuff in the cloud, you've got the ability to pivot a lot faster and answer those questions much sooner. And then you sort of answer them with a lot less permanency on your answers.
I wanted to add one more question. When you're doing a cluster build out, where do I put the old system while I'm building the new one? We're just going to turn it off for 6 months, and then we'll have a new one online. When we're done with the procurement, taking delivery, racking and stacking it, running the networking, provisioning it, burning it, doing acceptance tests.
And then, by the way, once you've done all of that, you've got to configure user management, put software on it, prepare file systems, set up the scheduler. I mean, it takes forever to get one of these systems running. And that's probably why it takes literally years from when you start designing one of these things before you're ready for the first job to run on it.
Yeah, and I know we've got at AWS a tool called Parallel Cluster that I know can help, do this faster at scale for customers. How are things different, with Parallel Cluster versus the traditional way of doing things?
Yep. Okay. Obviously, it's in the cloud, so there's a lot less hands and knees work. But like a lot of it's still the same. You get to do the fun part, which is you get to design your cluster, and you get to write all of that down. But with Parallel Cluster, once you've written that design down, you do it in a specially formatted file eventually. I mean, you might start on the whiteboard, but you end with a file. You're in the home stretch because you give that file to the Parallel Cluster software, and it uses that file to build your cluster for you. And it can include file systems, software, network interconnect, auto scaling, scheduler, all of that. And that can take as little as 10 minutes from start to finish once you give it the file.
Yeah, well, once I give it the file, it can take 10 minutes. But what happens if I change my mind and want to, change some of those configurations?
Your cluster design isn't locked in. So the source of truth for your cluster is this file. So if you want to change how things work, you want to add GPUs, you want to add a new queue, your cluster design isn't locked in. You edit the file, and Parallel Cluster will make the changes to the system for you. That's definitely something you can't do with an on-premises system. This is an approach that's called infrastructure as code. We actually have some resources about this on our blog and our YouTube channel. It's really common in the cloud computing world. Parallel Cluster brings it to HPC. Being able to adapt and experiment and change things as you go is one of my favorite things about doing HPC in the cloud.
And that ability to adapt and experiment to suit what your current needs are, that means that your needs can change. Well, actually, your needs change anyway, right? What is important this week is not necessarily what's important next month or next year. Obviously, things change. Governments change, industries change, fiscal pressures change. And when it does, and in fact, technology changes, of course, as well. And we've all seen what's happened in the last couple of years, particularly with the rapid rise of artificial intelligence and the techniques and tools around that. Your needs can change, and so the resources that you use to satisfy them can also change. And It's one of the best things about doing HPC in this cloud environment is you don't have to predict the future with perfect accuracy through your clairvoyant crystal ball. It takes the pressure off all of those decisions, and you can actually change your mind, which is what you should be able to do.
Well, it's hard to make predictions, especially about the future.
Oh, that goes into my dad jokes collection. Anyway, the other best thing about all of this stuff is you can expand and contract the clusters, right? If you're in an on-premises world, they don't. You've got a fixed thing, and it's a zero-sum game between all of your users because you only have a fixed number of nodes. Now, you translate that to the cloud. You've still got something fixed, and it's your budget. And that may actually mean you've still got effectively, when you translate dollars into core hours, you've still got a fixed number of core hours that you can really do in a day. But you could actually pile up those core hours in the middle of the day. You could get more work done when people are awake and less work done when they're asleep. And that may actually fit your needs, your actual business needs in your environment. So, and the cloud can do all of this. It can expand and contract the resources that it offers you. And Parallel Cluster has got a lot of tooling around being able to take advantage of that expansion and contraction. And so it's not just storage that gets bigger. Clusters can get bigger, and then they can get smaller when they're not needed.
If you're enjoying these videos, please give us a like and consider subscribing to the channel so that we can keep making more to help you understand how the cloud works and to show you new ways to help all the scientists and engineers around you who use HPC every day to do amazing things. It's what gets us motivated as well. See you next time.